Here I am. I'm a snow hydrologist talking about environmental quality and standards. So I'll try to not to make a fool of myself too much, and try to give you an overview of what's been going on in my country in terms of environmental protection and management. I'll try to cover a little bit of the story to make sense of how we are where we are right now, try to explain the main regulations and framework that, that deal with environmental protection and water quality in the country, and then explain, then go on to the motivation of why we would like to have secondary water quality and environmental standards, and then focus on a case study, which is the Maipo River Basin. The Maipo is one of the main rivers in the country for several reasons. While researching for this presentation, I tried to come up with a framework in terms of environmental water quality management, and try to come up with some kind of taxonomy of how you could go about dealing with this problem. And I found interesting information, and that was talking about the different approaches that you could find in the literature, and reviewing different examples. On one hand, you have government push kind of approaches, which we are all familiar with in terms that involve regulations, standards, norms, and limits, and those can be classified as well into emission limits, where you're telling somebody, an individual, industry, or any party, how much of any contaminant or pollutant can be discharged into a stream. Then you can have also use-related standards, or what we call primary standards, in which you establish the limits of certain contaminants or elements, actually, that are associated with certain uses, right? For drinking water, for direct contact recreation, and so on. And then those are also related to primary standards. And then you have secondary standards, in which you're looking at an environmental system, an aquatic system, and then you're trying to say what would be the desired quality that water body should have for whatever objectives you may have. Then some authors claim that this kind of approach is very inflexible, and might be inefficient in some cases. And a new push for non-mandatory approaches has been observed, with certain success in some cases or not. And these different approaches have to do with voluntary commitments by polluters, industries, and so on. Of course, always they involve some kind of conversation between the regulatory agency and the private parties or cities or whatever, what have you. But there is the perception that this could lead to better performance and more flexibility in some cases. Focusing on Chile, well, Chile, in 2011, there was a World Bank study that ranked Chile among one of the worst countries in the OCDE related to fragmentation of the water sector. We have over 100 functions functions related to water issues, and over 40-something agencies that have to do with those functions. So the system is quite fragmented and confusing at some points. However, if we focus and we look into like the big picture, we could find two main agencies, which are the Environmental Department, or Ministry of Environment, and the Ministry of Public Works. And those two departments of the government have major roles when it comes to water quality and environmental management. The Ministry of Environment, among its roles, is to drive and coordinate environmental policy, research the country's environmental baseline, the elaboration of environmental standards, coordinating information and monitoring efforts, also coordinating the environmental impact assessment system, which is important for us when it comes to making sure that new developments on different industries are compliant with environmental regulation. On the other hand, the Ministry of Public Works hosts the Water Directorate, which is in charge of all things water in terms of monitoring and research. Also, it's in charge of providing opinion on environmental impact assessment of different projects when it comes to water bodies. And on the other hand, we have the Superintendencia of Sanitary Services, which is an overseer agency that is in charge of controlling that individual discharges to water bodies meet emission standards. Also is in charge of establishing tariffs for drinking water every 5 years. Besides those three, or these two departments, we have the Department of Interior, Department of Housing, Department of Agriculture, Department of Energy. All these agencies have something to do or have something to say when it comes to water regulation and water institutional framework. And then what happens many times is that the sectorial or the individual agendas of these departments are sometimes in conflict, and then they generate some problems when it comes to water management. The evolution of the regulatory framework in Chile looks roughly like this timeline shows here. In 1916, we find one of the first law bodies that forbids industrial activities to discharge liquid waste into a natural body without treatment. Then we have to wait all the way until 1978 to find a new regulatory body, which is a Chilean norm, Standard 1333, which regulates water quality for different uses. And this is quite a comprehensive standard in the sense that it lists various different uses and establishes the maximum concentrations of different elements in the water that are appropriate for each and every one of those uses. In 1981, we find the Chilean Water Code, which is an important milestone because it establishes the way water is managed in our country today, which is a special way if you know anything about Chilean water systems, because it established that water is a public good, but at the same time it established private water rights that are private goods, 100% private goods, which you can sell, rent, buy, inherit it, and are independent from the land as well. So it poses its own complexities when it comes to dealing with water issues. In 1984, we find water standards for human consumption, which are also extensive for animal consumption as well. And in 1994, an important milestone is the first Environmental Protection Act in Chile, which established the environmental impact assessment processes and established also the potential for future regulation in terms of environmental quality standards. In 1985, we find a couple of other regulations that deal with the framework for primary and secondary standard emission limits and environmental cleanup regulatory framework. So these are like rules of how to go about establishing these plans. Chile also has evolved in terms of its knowledge of environmental systems. I don't know if you can see this figure very well, but what this plot shows, I just did a short search on Scopus on the terms water quality and Chile. And the time, it's 1983 to 2014, and the y-axis is number of documents. So this is the number of research papers appearing in Scopus database over the last 30-something years, from 0 to 80. So you can see there's a steady increase with some noise in the number of publications appearing that relate to water quality in Chile. Very few before 1996, and then a steady rise from 1986, which is more or less when the Environmental Water Act or Environmental Act was passed. So this is consistent and coherent with an increased interest and increased knowledge, and then also an increasing number of researchers in the country dealing with these kinds of problems. So as the level of knowledge and as the institutional framework got more complex and more sophisticated, there was an increased understanding that more refined, more specific institutional framework was needed to deal with the extreme diversity that we can find in Chile's water systems that has to do with the extreme geography and the very large climatic gradients that we can see in our country. So these are three pictures that show examples of our different water systems. Of course, there's many more because I'm not adding any coastal systems here, but you can see on the left-hand side, left upper hand, this is northern Chile, and this is very similar to some of the pictures that Fernando was showing us yesterday. Then we have here the central part of the country, which is dominated by the Andes Cordillera and mountain rivers. This is the Maipo River here. And then we have the southern part of the country, Patagonia, high precipitation, low temperatures, very large volumes of water, very little population. This graph here also is just to reinforce this point. This shows the availability of water per habitant, per person along Chile. These are the different administrative regions from north to south, and this is a logarithmic scale from 1 to 100,000 million, or 10 million, I can see, 10 million cubic meters per person per year. So you can see there's an increasing availability to the south, and here this number is important because we have 1,000 here, and 1,000 cubic meters per person per year is an important limit because it establishes water stress when it comes to understanding human and water interactions. So geographically, at least one half of the country is below this limit, and in terms of population, it's more than one half of the population of the country which is living in water-stressed conditions. Okay, so when moving into secondary standards, the regulation in 1995 established the procedures for coming up with environmental quality standards, which is the secondary standards. And the regulation is very clear. There are a number of steps that are required to generate these regulations. This involved a technical and cost-benefit analysis. The cost-benefit analysis has to do with the amount of money required for monitoring and control, but also the amount of money that would be required for cleanup in case some of the standards were not met. It establishes the need for a scientific basis for all proposals. When I say proposal, I mean a proposal for a secondary standard for an individual watershed or water body. It established a period for private and public institution opinions, so everybody is welcome to comment on these proposals and offer their opinion. Then the analysis of this received opinion, the public dissemination. So it's there's an important stress on transparency and public information about anything that's going on. Then criteria for local application and a procedure for a periodical revision of the standard every 5 years. In 2007, the first drafts for secondary standards were submitted, submitted by the Ministry of Environment. 3 watersheds were proposed at the time, and one of those watersheds was the Maipo River Basin. The preliminary version of the secondary standard was approved in 2014, so after 7 years of a process, and it was revised in the first few months of 2014, and the final version was approved in July last year. This is a figure that shows the Maipo River Basin. It shows the general position. This is Chile, and this is central Chile. The Maipo River Basin is right here. It's a roughly 30,000 square kilometer basin. All our river basins are very small, so I don't apologize for that, but they are very small. Our rivers are tiny. Chile is very narrow. The gradient from sea level to the border with Argentina, we have 6,000 meters of elevation gain over less than 200 kilometers, and this makes for interesting hydrology as well. Here we see the city of Santiago, the capital of the country, 7 million people more or less. The coastal range is here, there's a central valley here, and the Andes Mountains are here. The upper basin is roughly 5,000 square kilometers. The river is snow dominated in its regime here. The important agriculture in this part of the basin as well. And here also in this map you can see some of other uses of water. In yellow dots you can see some of the mining activity happening in the basin. In this lining bolts here indicate hydropower facilities, urban use, agricultural use. 40% of all the drinking water produced in the country is consumed in this watershed. It amounts more or less to 22 cubic meters per second for almost all the inhabitants of the region of the watershed. We have 100,000 hectares of irrigated agriculture. Some of mostly high value crops, vineyards, fruit, some alfalfa too. Then we have mining, copper and molybdenum mining, also some minor operations on gypsum mining, and 16 power plants that use roughly 170 cubic meters per second with 360 megawatts of installed power. Municipal water use is interesting. It's concentrated on one company, mostly on one company. It's a private company. Chile privatized its water utilities in the mid-1990s, and Chile has done a good job in providing coverage of drinking water, sewage collection, and water treatment in the last 10 years. Many people say thanks to that private investment. This is a picture of the La Farfana water treatment plant, which at the time of its construction was the largest in South America. It had its operational problems at the beginning. Several lawsuits were involved in this, but nowadays, for the most part, it's operating appropriately. Here's just a picture to show the irrigation landscape and how that looks in the country. The mining happens in the headwaters of the basin, and of course this is a major point of concern for many people. As you could see, geographically it's not widespread. It's concentrated in a few points. This is a picture of the Los Bronces mining site. Here you have the Aconcagua mountain, the tallest mountain in South America, and this is a large copper ore in the headwaters of the Maipo River basin. In hydropower, it's been an interesting times because Chile needs energy, and companies are trying to find this energy wherever they can. This is the figure of a new project that is being proposed in the upper Maipo River basin. It's called Alto Maipo, and it involves a series of tunnels that would collect water in many of these mountain rivers to generate electricity, mostly in this area here. So it has driven complaints and protests from people living in this valley because it would divert a significant amount of water from these river reaches. And regarding other uses of water, you can see tourism, rafting in the Maipo River basin here, and also use of water, which is an indirect, which has to do with gravel mining along the river reaches. So environmental standards require a baseline, and I'm taking these figures from a PhD thesis from Imperial College, a Chilean student that studied the geochemistry of the Maipo River, and I'm just showing this to give you an idea of how the water chemistry looked like in this area. It's quite dominated by calcium, sulfate, and carbonate as well. This is has to do with the geology of the Andes, and it's not surprising given that there's mining also ores over there. This is a spatial representation of some water quality and elements. There's a bunch of these in the thesis, but I'm just showing two, which is pH and arsenic. And you can see here the concentrations and the areas where pH it's very low. Many of these areas with low pH are associated with natural lixiviation of minerals, and also we can see some arsenic in the surface waters here coming from seepage of subsurface waters here. The basin is also being subject to rapid change. These are scenarios of climate change for the area, for the watershed, that have been recently developed in a research project I'm involved with. These are temperature and precipitation in absolute values, and then deviations in degrees Celsius and percentage points of precipitation for the window 2020-2050 for a high elevation station in the upper reaches. So you can see here it's depending on the scenario that we're dealing with, and this is I don't know if you're familiar with this, representative concentration pathways. These are climate change scenarios that deal with or try to express how much of radiation forcing would be added by greenhouse gases on the atmosphere. So these are less severe scenarios, and the triangles are more severe scenarios. In case you didn't know, we are on the trajectory of the most severe scenarios currently, so these are pretty you can be pretty confident that we would be somewhere here. And we're talking about warmings of about 1 degree Celsius in the upper reaches of the basin, and drying between -10 or 10%, 30% less precipitation for the next few decades. Also, land use is changing. This is a figure that shows land use change patterns under a business as usual scenario. And you can see increases of urban areas, decreases of agricultural areas. So coming to the secondary standard objectives that have been approved, the idea is to, in the law, what is said is to preserve or to conserve aquatic ecosystems and their associated services through the maintaining or improvement or water quality in the basin. And I don't expect to explain this figure, but this is just to show when we talk about ecosystem services, things become very, very interesting. And this map, you will have this for yourself to study on the plane going back to your countries. Is a diagram that shows the linkage between ecosystem services and water quantities and quality. These are the limits, which are probably not that interesting at this point. You can check them by yourself. The implementation of the standard involves a monitoring plan, which has to be presented by governmental agencies, monthly sampling at select locations, standards for sampling, managing, and laboratory analysis, and the possibility of ecotoxicology and bioindicator analysis in the first few years of the implementation of the standard. The non-compliance of the standard, and this is important, happens when the 19th percentile of the continuous 3-year monitoring series is not met. And this was a point of contention because the initial draft of the standard said the 66th percentile, which was very lax. And now it was moved to 95th percentile. So after 20 years of environmental legislation, the first environmental quality standards were established in Chile last year. They have not been fully implemented, and we are all excited to see which effects they would have. A 6-year process was required to come up with the first 3 basin proposals. And one of the things that delayed this process was the disagreements on cost-benefit analysis, which would set different, which would define the feasibility of applying these standards for the basins that were studied. So with that, I leave you. Thank you.